Hello all. So we were looking at the power series solution of the second order ODE about an ordinary point. So in today's class we'll see a theorem regarding this, and we'll see a few more problems of finding the power series solution. So the theorem, so we do not have the proof, so just only the theorem. So the theorem states that so let x naught be an ordinary point of the differential equation y double dash plus py dash plus qy equal to 0. So x naught എന്ന് പറയുന്നത് ഈ differential equation ordinary point ആണ്. So p and q, they will be analytic about x naught, and let alpha and beta be arbitrary real constants. So if alpha and beta are arbitrary real constants, and if x naught is an ordinary singular point, then there exists ordinary point, then there exists a unique real analytic function y equal to y of x that has a power series expansion about x naught, so that y solves the differential equation and function y satisfies the initial condition y at x naught equal to alpha and y dash at x naught equal to beta. So provided x naught is an ordinary point, then you can find a power series solution, a unique power series solution about x naught. So this solution y equal to y of x will satisfy the differential equation, and you can find y such that it satisfies the initial condition y at x naught equal to alpha and y dash at x naught equal to beta. If the functions p and q have power series expansion about x naught with radius of convergence r, then so does y. So here p and q നമ്മൾ എടുത്തിരിക്കുന്നത് analytic functions ആണ്. p and q are analytic about x naught. So if they are having the functions p and q are analytic, and if they have a radius of convergence r, then the series expansion, so y will have a series expansion about x naught, so that also will have the radius of convergence r. So that is this theorem. So നമ്മുടെ ordinary പോയിന്റിൽ second order differential equation എപ്പോഴും ഒരു unique power series solution ഉണ്ടാവും, and if p and q are having the radius of convergence r, then the radius of convergence of the given power series solution will be the same. Now let us see an example. Okay, so let us look at the solution of second order differential equation. So find the general solution of the equation 1 plus x square y double dash plus 2x y dash minus 2y equal to 0 in terms of power series in x, and can you express the solution by means of elementary functions. So here you have in the form y double dash, so p is 2 by 1 plus x square and q is minus 2 by 1 plus x square. So x equal to 0 എന്ന് പറയുന്ന ordinary point ആണ്. p യും q യും analytic ആണ് about x equal to 0. So it will have a power series solution in x. So let y equal to summation an x bar n be the solution. So we will find y dash will be summation n equal to 1 to infinity nan x raised to n minus 1, and y double dash will be summation n equal to 2 to infinity n into n minus 1 an x raised to n minus 2. Now let us substitute y double dash and y into this equation. So that will give me this 1 plus x square into y double dash in the series plus 2x into y dash in the series minus 2 into y in the series. What we okay, so let us remove all the brackets, so multiply jaya. So you'll get summation n equal to 2 to infinity n into n minus 1 an x raised to n minus 2, then x square കൊണ്ട് multiply ചെയ്യാം, അപ്പം plus summation n equal to 2 to infinity n into n minus 1 an x raised to n varum. Then here x 2x agathékku multiply cheya, appo summation n equal to 1 to infinity 2n an x bar n, then minus summation n equal to 0 to infinity 2an x bar n equal to 0. Now here you have the coefficient as x bar n minus 2. So let us make the coefficient as x bar n. I'll start summation from 0 to infinity. So n will be replaced by n plus 2. So n plus 2 into the n plus 1 now an plus 2 x bar n plus in baaki ella terms x bar n aanu. So what we are going to do is we'll equate the coefficient of x bar n on both sides. So that will be equal to 0. കാരണം right hand side 0 ആണ്. അപ്പോൾ left x bar n the coefficient 0 ആണ്. So taking the coefficient of x bar n we will get n plus 2 into n plus 1 an plus 2 ഇവിടെ plus n into n minus 1 an plus 2n an minus 2an equal to 0. So this is the equation we are getting. So from that we will get an plus 2 equal to minus, so this is n square minus n plus 2n minus 2 into an by n plus 2 into n plus 1. So when you simplify, you will get an plus 2 equal to minus n square plus n minus 2 into an by n plus 2 into n plus 1. In the numerator, we factorize either. Okay. So you can write it as n plus 2 into n minus 1. So n plus 2 will cancel off. So we are going to get an plus 2 equal to minus n minus 1 an by n plus 1. So here n will start from 0 onwards. Okay. അപ്പോൾ നമുക്ക് a2 ന്റെ value കിട്ടും. a2 ന്റെ value. So you will get a0. When n is 0, you will get a2. So that is a0 by 1. So a2 will be equal to a0. In a3, when n is 1, you will get a3. So a3 the value 0 out. In a4 എന്ന് പറയുന്നത് അതായത് n equal to 2 എടുക്കും. അപ്പോൾ minus a2 by 3 വരും. Again a5 is in terms of a3. So that is again 0. a6 minus 3 by 5. അതായത് n equal to 4 എടുക്കുമ്പോഴാണ് a6 വരിക. Minus 3 by 5 a4. So which is a2 by 5. അടുത്ത again a7. a5 ന്റെ ടേംസിലായിരിക്കും. അപ്പോൾ a7 0 ആണ്. So now let us write the solution. So you will get y equal to a0 plus a1x plus a2x square plus a3x cube plus etc. So substituting all the coefficients. So this is what you are going to get. a0 plus a1x, a0 x square minus a2 by 3 x raised to 4, then 0, a2 by 5 x to the power 6 plus etc. So a0 again, a2 will be equal to a0. അപ്പം നമുക്ക് a0 വരുന്ന ടേംസ് വരും, അതുപോലെ a1 വരുന്ന ടേം ഒരു ടേമേ ഉള്ളൂ, ബാക്കിയെല്ലാം a0 വരുന്ന ടേംസ് ആയിരിക്കും. So there will be a0 into 1 plus x square minus x raised to 4 by 3 plus x raised to 6 by 5 plus etc. Plus a1x. Now this series ഇനി നമുക്ക് ഏതെങ്കിലും elementary functionന്റെ ആയിട്ട് എഴുതാൻ പറ്റുമെന്നാണ് ചോദിച്ചിരിക്കുന്നത്. So here I will get a0 into 1 plus x into, so when I take x outside, I am getting x minus x cube by 3 plus x raised to 5 by 5 minus etc. Plus a1x. Now this is the series for tan inverse of x. So we will be getting a0 into 1 plus x into tan inverse of x plus a1x. So your solution is in the form a0 y1 plus a1 y2. So these are the two independent solutions. Now let us look at one more problem. So consider the equation y double dash plus xy dash plus y equal to 0. So you are asked to find the general solution y equal to summation over j aj x bar j in the form y equal to c1 y1 plus c2 y2, where y1 and y2 are power series, and use a ratio test to check that the two series y1 and y2 converges for all x. So we need to do two things on the power series solution kandupidikka. So you need to take the form summation aj x bar j and find the series y1 and y2. Okay, functions ആയിട്ട് കണ്ടുപിടിക്കണം നിർബന്ധമില്ല, series കണ്ടുപിടിക്കുക, then show that the radius of convergence is infinity. It converges for all x. Okay, so let us start with y equal to summation n equal to 0 to infinity a n x bar n. Let this be a solution. So we need y dash and y double dash. So we have y dash and y double dash. Substituting in the equation, you will get y double dash plus xy dash plus y equal to 0. So substitute the y value and the derivatives. So this is what you are going to get. ഇനി x ഉള്ളിലേക്ക് multiply ചെയ്യുക. അപ്പോൾ x multiply ചെയ്ത് കഴിയുമ്പോൾ you will get summation n equal to summation n equal to 2 to infinity n into n minus 1 a n x bar n minus 2, that is y double dash, plus x into summation n equal to 1 to infinity n a n x bar n minus 1 plus summation n equal to 0 to infinity a n x bar n equal to 0. Now എല്ലാത്തിന്റെയും coefficient second and third term ന്റെ coefficient third term x bar n വരും, first term x bar n ആക്കുക. So n will start from 0 to infinity. So n will be replaced by n plus 2. So you will get n plus 2 into n plus 1 into an plus 2 x bar n plus summation n equal to 1 to infinity n a n x bar n plus summation n equal to 0 to infinity a n x bar n equal to 0. Now equating the coefficients. So this is the equation we are going to get. So n plus 2 into n plus 1 into an plus 2 plus n a n plus a n will be equal to 0. So now we can write a n plus 2 എന്ന് പറയുന്ന minus n plus 1 a n by n plus 2 into n plus 1. So n plus 1 will cancel off. So we'll get minus a n by n plus 2. So now we can write the values of a2, a3, a4, etc. So a2 will be minus a0 by 2, a3 in the value minus a1 by 3 varum, then a4 will be minus a2 by 4, a5 will be minus a3 by 5, so on. So now replacing a2, a3, so on. അപ്പോൾ നമുക്ക് a0ന്റെയും a1ന്റെയും ടേംസിൽ എല്ലാ കോഎഫിഷ്യൻസും കിട്ടും. So a2 is minus a0 by 2, a3 is minus a1 by 3. So when you find a4 will be a0 by 2 into 4, a5 will be a1 by 3 into 5 varum, a6 minus a0 by 2 into 4 into 6, അതുപോലെ a7 minus a1 by 3 into 5 into 7. So it will proceed in that form. So therefore now when you write the power series solution, so therefore y will be a0 plus a1x minus a0 x square by 2 minus a1 x cube by 3, then plus a0 x bar 4 by 2 into 4, then plus a1 x bar 5 by 3 into 5, then minus varum. Then again alternatively രണ്ട് terms plus അത് കഴിഞ്ഞ് വീണ്ടും രണ്ട് terms minus ആവും, then again plus. So you can write as a0 into, so this is the first series, and a1 into x minus x cube by 3 plus x bar 5 by 3 into 5, so on. So this is your y1 and y2. So these are the so solution is of the form y equal to c1 y1 plus c2 y2. So where the power series of y1 and y2 is given by this.